Regular expressions. Okay, so we are talking about regular expressions today. Hooray, hooray, hooray. Hurrah, hurrah. So I've mentioned before that this can get pretty complicated pretty quickly. And that is, I am still hanging on to that as an example. You're going to see why and how in a few minutes, just as we kind of go through what they might look like. But uh, they are, because it's very powerful, it can be complex. I think that's the thing you got to kind of remember. So let's first talk about what is regular expressions used for. And there's used for two different purposes. One is a find and replace type of operation. Um, so you can build a regular expression and say, and I'll give you a perfect example of this in just a minute. You've got, company X, and you want to go and scan through a file, and every time company X is listed, you want to replace the name with company Y. I had as a perfect example of that. I was asked to replace when my company got bought out a few years ago. I was asked to go and replace every instance of the old company name. So I started doing searches. I told and people come back to me like, 6 months later, you forgot one, you missed one, you need to fix this right away. I'm like, I'm sorry, I changed 17,000 different places. Anyway, you did not. I said, oh yes, I did. I kept track. And a big part of what we did is we went in and ran search patterns to find that phrase and then replace it with another. And I think when all was said and done, I wound up replacing over 19,000 different instances of where the company name was. And so when I missed one, I didn't really sweat too much about it, no matter how loud someone was yelling, because I was like, that's like 0.02% of the total ones out there. I'm pretty sure I changed more than anyone else, so lay off. Uh, that was kind of my attitude when I was dealing with it. So using it for find and replace is definitely one big way that you'll find something used in a regular expression. And this is a perfect example of that. The second is for checking validation. So if you think about going back to the ETL, extract, transform, and load data, one of the things that we have to do is we have to convert data, and a lot of times needing to know, is this data properly formatted, becomes real important. The problem is with that formatting, is it the correct formatting? Is it incorrect? Is my data bad? I did some, in one of the processes I was looking at, I told them that, look, this data you gave us is garbage. They said, well, how can you say it's garbage? And I said, over 30% of the record fields you gave us are incorrectly formatted. And part of the reason you're able to go and do that is using the idea of a regular expression to go through and say, does this data match the way data is supposed to look? Now, sometimes it's real obvious. If I'm expecting a phone number and I get, all string text, that's an obvious answer. But sometimes it's less obvious, like, how do I format a phone number if it needs to be formatted in a special way? Or what happens if I have a string of text and I get a string of text? Is it easy to tell that there's an issue or not? So that's where regular expressions really comes in to play. And the idea came out of a mathematical application from the 1950s, but it really wasn't used until the 80s under what's called POSIX. And POSIX is just a really well-known implementation of rules. There's actually 3 different ones for regular expressions, easy regular expressions, and extended regular expressions. Each one is, regular expressions is kind of the one that most commonly used. There's an easier form that doesn't have all the features, and then there's like a super extended one that was really complicated. We're just going to look at the real basic things. So what we're going to search for is usually called a token or a pattern. And that's just going to be what is it that we're looking for. And most typically, the token's going to contain, needs to be several characters long. So a lot of languages have regular expressions built into it now. Each one has their own little interpretation depending upon how they're going to do it. And they're going to vary on stupid stuff. Like, for example, should the pattern that you're looking for be enclosed inside of quotes or not? And you might go, well, it's like a string of tokens, right? So why wouldn't it be enclosed inside of quotes? Well, other languages enclose inside of slashes. I don't know why. That's what they chose. So there's weird stuff like that you gotta kind of be careful of. Those are two most common ones. And all of our basic rules can be broken up into several basic categories. So I can list something specifically. Like I can say, hey, I want to find the word at, and anytime I find at, I'm good. But that's really limiting. I want to be able to find wildcards. So I have in here an example of a.e. The period is a wildcard inside of a regular expression. And it says I can replace this with any character I want. So I can say ape, I can say eight, I can say ale, I can say all different types of things like that. Unfortunately, I could put numbers in there, I could put symbols in there, I could put AZE, which isn't a word. So I could, if I'm looking for all the words that are start with an A and have three letters and end with an E, I don't necessarily want to use a wildcard because that's too open. I mean, find something else. So I can say, well, since I can put in the whole specific word, I can use what's known as a Boolean OR. And a Boolean OR is going to allow me to check a couple of values, this value or that value. Or I can use it multiple times and find multiple values. So for example, I can say ape, pipe, eight, pipe, ale. Now this only comes up if one of those three specific values were found. And that makes it a whole lot easier for us. Now, this is with some assumptions like it's not going to matter if it's found in the middle of a word and stuff like that. We're ignoring stuff like that. So, for example, APE would be found ape, but if I don't care where it's found or if it's bordered by word boundaries, grape would also be found. 8 would be found, but so would great. Or like a metal grate, not great like you're great, great like you find on the road. So with gale, if you're talking about like gale force winds and stuff like that. So we're ignoring stuff like that for now. We're just looking at what we're actually finding. Unfortunately, if I have to write out all my possible combinations, this becomes a little bit complex, a little bit troublesome. So therefore, we can find a grouping. And a grouping says, I'm going to put something inside of parentheses, and I'm going to look at one of these. Excuse me. So I can group this together and say A, and then P or T or L, and then finishing off with an E. This is equivalent to this. But I think everyone would probably agree that this is easier to read, but this is smaller. This might be less likely to make mistakes because I might, not mix up letters beginning and end, but trying to keep track of what it is. And this is where the complexity of regular expressions starts to come into play. How do I build something like this out? Okay. I can also use brackets that will allow me to define any character found within the brackets, so I don't have to use all those piping OR statements. Pipes for my OR is great, especially if I have multiple letters. And I can do that with multiple letters. But if I just have a single letter, I can find square brackets, for example, and do ABC. This is any A, B, or C. It will find and will return a true for. Unfortunately, that's kind of limiting. If I want to route the alphabet, A, B, C, D, E, F, G, that takes a really time for me. So what can I do? Well, I can create what's known as a range. And I can say, inside my square brackets, A-C. And that will find me any letter A to Z. Notice how it's lowercase. By default, regular expressions is case sensitive, which means it would not find uppercase letters. So if I want to do uppercase, I could do square brackets, A to Z lowercase, and then A to Z uppercase. And that's going to give me any letter upper or lowercase. I can mix this up and I can include things like numbers in here. So for example, and we'll see an example a little bit later on of if I want to determine a valid instance name for C++. They can have numbers inside of them. You can have a variable name, color2. That's a valid variable name. So I need to be able to look for letters and numbers and underscores and some other stuff. Okay. How many? Well, here's some quantifications. And quantifications allows us to specify how often should a pattern be found. So for example, here's color with a question mark after the U. You might go, why is a question mark after the U? Well, it's looking for color where it's C-O-L-O-R, and the U says 0 or 1 times it will be found. So whether I spell it the English way, or excuse me, I should say the American way. The English would get upset if I called that the English way. Or the English way with an O-U-R, it finds both of them. Just as an example there. Okay, so the question mark will find where that preceding character is 0 or 1 times. Now, if something's inside of a parentheses, it looks for that group 0 or 1 times. If it's inside of a bracket, anything that matches inside that bracket must occur 0 or 1 times. If I use an asterisk, it could be 0 or more occurrences. So it doesn't have to occur, but it could occur a lot of times. So the asterisk allows you to occur things over and over and over again. You see some matches down below. On the other hand, they have a plus symbol, which is it must occur at least once, but could occur many times. So the plus and the asterisk are very similar. The difference is the asterisk is optional. The plus is required, but it could be occurring many times. If I use braces, I can put a letter in and it must occur X number of times, must occur that many number of times. Now, obviously, you're not going to do it if it occurs just once, obviously. However, if something needs to occur 5 times or 3 times, we'll see an example of that in just a minute. If it needs to occur a minimum number of times, let's say it must occur at least 3 times, but could occur more, you can specify that number and then a comma, and that maximum lets it occur multiple times. And just the only difference in the previous example is it adds a comma. And then you have a min and max, so sometime within this range. So here's an example down below I created of what a social security number is going to look like. Inside my square brackets, I have 0 to 9, and then inside my braces, I have 3. Your standard U.S. Social Security number is 3 digits, a dash, 2 digits, a dash, and then 4 digits, right? So I have 0 through 9 3 times, dash, 0 to 9 2 times, dash, 0 to 9 4 times. So this will check for a valid Social Security number as long as those Social Security numbers, there's nothing in there that won't cause an issue. A phone number, for example, doesn't do that as nearly as well because a phone number has optional characters. Like, do I want to use a dash as a separator or a period? Do I want parentheses around my area code or not? And that's not even getting started with what international phone numbers look like. It's looking out for internal U.S. phone numbers. This is an example of what a C++ identifier would look like. So some of the old C++ compilers said that your variable and function names couldn't be more than 32 characters long. So, and a variable or function name must start with a letter. So here we start with a letter. We specify it must occur one time. And then we specify that you can have uppercase, lowercase, underscores, or a number between 0 and 31 times. So that gives us a total of 32 characters, and it allows, since it can be 0, we can have int I, that works, but I can't have int 3, that would not work. I can have circle 2, that works. 2 circle does not work. In modern compilers, you can have between 1, your identifier can be between 1 and technically an infinite number of values. There probably is a hard limit in there somewhere, 256, 512, but we used to use a star since that's not specified. So just one little change changes dramatically what it's going to look like. If I go into here, I need to close the solution. Come here, my regular expression. Okay, so here I built in my pattern that I'm going to search for. This is for social security numbers. And often what we're going to do when we work on something like this is I want to test, and sometimes they call this red light, green light testing. I want to test to see, okay, does it find something I know is going to match true? And is it going to find something I know that's going to match false? So, and I'm going to look at different things. So here's a correct format. Here's the exact same format, but without dashes. Okay, so will these both match? Here's the correct format with dashes. Here's the correct format with dashes. Here's the exact same number as the previous one, but it starts off with an extra dash. And here we have some special characters instead of a dash. So if I go and run this, this is a social security number. This is not. This is. Oh, it said that is a social security number. That should not have happened. That should have failed. And then this is not. So I would look at this and go, why is that failing? I need to know. That's an important question. Why has it matched when it's not supposed to? So if I look at this, I create a regular expression based on this pattern. I then have an array of test strings, and I say for each string test, so it's finding out each element inside of my test strings. This is kind of like going through and saying for int I equals 0, I less than test strings dot length, I plus plus, but it's just a little bit simpler to write. That's the for each command. So I'm wondering, it's like, okay, why did this come back as a positive? It was a social security number when it's not supposed to be. And so I might say, well, let me try something else. I'm going to say, what happens if I put a dash at the end of a social security number? Okay, so this should not be a social security number. So if I go and run this, it's saying it is a social security number. That's not right. Okay, so I'm going to start thinking, okay, why is this providing false positives? And I can come over here and say something like a whole bunch of gibberish, and that's still showing up as a social security number. So one of the things that a regular expression does, just as an FYI, is that it is looking to find, did this match occur? Not is it the whole string, but did it occur? And if it occurred somewhere inside of my string, I'm going to show true. So I can get false positives if I'm looking for a whole value and it found part of it and not the other. So this is where we can do some pattern modifications to this. So I'm going to say RegEx options dot, and then I have some other values in here I can look at. So for example, I can check right to left. So if I'm using like an Arabic language or a Far East language that reads right to left, both of those, for example, do. A lot of cases we can check for that. I can check to ignore the case. I can check to see if it's compiled or single line or different things like that. One of the things I'd have to look for is, and I did not see it in here. Let me see it. Come back, pull it up. Let's see if explicit capture. I can't remember if that one fixes it or not. Okay, it does not. One of the things I can check and see is, does my regular expression begin and end with this? Does my test phrase begin and end with this whole option? Or does it have to be just found inside of it? That's one option I can run into. I can also check for a global pattern. So I can say, find how many in this big paragraph or this big text file, how many times does the old company name is it found? And then I can, say, oh, it's found 18 times, or it's found 23 times, or 2 times, or whatever that number is. So my regular expression will usually return a true/false type of value, but it can return others as well. You just have to kind of know what it is. Um, you'll notice inside of C#, it's going to be my test string or my test string that I'm testing against. And then it's got a second option that says, where do I want to start at? So for example, if I don't want to start after a certain, or I do need to start after a certain character. So I don't care about the first 100 words or 100 characters. I can start at another location. So it just kind of gives you a couple different things. So this is a start. I can do searches for globals. I can do searches for others. If I, oops, not that one. If, oh, I got rid of it. The uh, so if you look at some of these extended characters, you'll see here like the $ ends at the ending location. The caret starts, it must start with this match, and some other things that you can use as far as how that goes. So there's some other things in here that you can locate to kind of work with this. This is where you start to get more and more complex with how big and crazy and such that this can wind up being. So but I did want to kind of point out that the caret says it's a match. The $ says it must, or excuse me, match must start at the beginning of the line. $ it must stop at the end, start at the end. And if you kind of work with putting those together, they can say, I want it just to be this match. So if we're to do, I believe it is that, and then I believe is that. Oh, it did not like that. Didn't like that. That's what I didn't like. Now, because I put the caret at the beginning and say it must start here and it must end here, this still showed as a valid SSN. This did not. This did not now because now it's not ending with a number or specifically 4 numbers. This is failing because it doesn't start with 3 numbers. It starts with a dash. And then this failed because there weren't numbers in the center. So making that little change had a big effect, and that allowed us to fix the way we work. Now, all of my if I were to be running this in like a unit test, where I had red light test, where I said, okay, this should pass, this should fail. Now all those tests would work. So that's a big help for how I want to kind of test my applications as I move with them. Excuse me. Any questions that you might have? None? Sweet. All right. If you missed anything from before, I've posted all these class videos and stuff online, so you can go back and take a look at them. If they're not on Moodle, I know I've posted the
playlist.
Yeah, the playlist, so you can go find it there. I want to give the rest of today to let you guys be working on the Game of Life project that you guys are working on. If you have any questions with that, I'll be sticking around to answer those types of things. So that way you've got some options as far as that goes. If you're good and you're moving along fine, then that's great, and you can just keep on working on your own. So whatever you guys feel is best.